So in the last video, we talked about the law of sines, and now we're talking about the law of cosines. So here's the formula for law of cosines, which kind of looks like the Pythagorean theorem, but it has a little extra on it. So let's talk about where does that little extra come from. So what we're gonna do is look at coordinate geometry for this. So in our picture, I just put a triangle. Notice it's not a right triangle. And I made my A at 0, 0, B is at X, Y, and C is at B, comma 0. So we're just labeling the side across from angle B is B, okay? And then I've got A and then C, and those are across from angle A and angle C. So the only thing I am going to use, though, is B is going across the x-axis, so this point C is B, comma 0. The angle B, this point B right here, is x, comma y. So it's just some random x, y coordinate. So in order to think about this, I want to drop down an altitude. Okay, so that we have right triangles. So over here I have C, but keep in mind that the length of from A to this point, let's call this point D, just so we can talk about it. We'll call this point D where the altitude is. Okay, that's point D. Remember, that would be x, comma 0. So that side from A to D, this side has a length of x, and then the height of this from B to D is just the height of y. Okay, now going over to the other triangle, we still have that height is y, this side is A, but now this side is not all of B, right? It's going from D to C, that's from B, but I have to subtract off this x value, so that's B minus x. Okay, so what we're going to do, we're going to just try to not necessarily prove, but just convince yourself why the formula for law of cosines is the way it is. And do you notice how it starts with, in the one that we're using, we're starting with the a squared. Okay, so I'm going to actually do step 2 first. We're going to write an expression for a squared. Right, so when we talk about lowercase a, we're talking about this side. So we're going to use that right triangle that we made on the right-hand side, and we're going to do Pythagorean theorem. So if I do that, a squared is my hypotenuse. So I'm going to have y squared plus, here I'm going to have b minus x squared. That's the other leg of that right triangle, and that's equal to the hypotenuse squared. Okay, so if I do that, I have to FOIL this out. This is not b squared minus x squared. I have to do, remember, b minus x squared is equal to b minus x times b minus x. Okay, so if I do that, that's going to give me b squared minus 2bx plus x squared. So if you FOIL that out, that's what you get. And then I get all of that is equal to a squared. So if I rearrange that a little bit, then I get this expression. All right, there we go. So all I did was I put a squared on the left just to make it look more like what we were dealing with up there. And then I put my b squared minus 2bx, and then I put the x squared and the y squared together. So the x squared and the y squared I got put together here and here. All right, so I just rearranged it a little bit. So what's the significance of that? That still doesn't look like what we have up there with the law of cosines. So what we're going to do is notice that in the law of cosines, I only have A's, B's, and C's, and then this angle A. So I don't have X's and Y's. Okay, so I need to replace those. So that's what step 1 is all about. We're going to write c squared in terms of x and y, and then we're going to write an expression for x, because we're trying to replace x squared and y squared. So that's when we move over to the other right triangle, the one on the left. Notice that if I do the Pythagorean theorem there, I get x squared plus y squared equals c squared. Right, so that can help me replace that x squared plus y squared. right, so that gets replaced with c squared. And then just a plain old x, that's where we're going to use our SOHCAHTOA. So if I do x, if I use angle A, here's my angle. All right, I have C and A though. I want C and then this angle A. So I am using the adjacent side and then the hypotenuse. So that means cosine of my angle A is equal to x over C. So then if I just rearrange that a little bit, then I'm going to get x is equal to C times the cosine of A. So all we did is multiply both sides by the C. All right, so then what does that mean? I can replace x with that C times the cosine of A. So if I do all of that replacement, then I have a squared equals b squared plus c squared minus 2bc cosine of A. All right, so you can see that's what the law of cosine says. Okay, so let's use it. When we use this, make sure that you're following order of operations. You're going to have one side squared. These will be the other two, so it doesn't really matter what letters you choose. Just make sure that over here on the right-hand side, the two letters that you're doing a squared plus b squared, that's going to be the 2ab part. And then the cosine of the angle is going to be the angle that's in between those two sides. Okay, so this is really useful for side angle side situation. So again, I have, this is my A, and then this is like my angle A. So then this would be like B and C. So we want to use the a squared equals b squared plus c squared minus 2bc cosine of A. All right, we're using that version. All you're doing is plugging in what you know. So a squared equals, my b is 20, c is 13, and then we're plugging that in again. Oop, I did that backwards. That's all right. It's all multiplied. And then cosine of 66 degrees. All right, so the variable that we're solving for is already isolated on the left. So now we're just plugging things in. So 20 squared is 400, 13 squared is 169, and then I'm going to type all of this in at once. So I'm going to do minus, let's see, 2 times 13 times 20 times cosine of 66, which is 211.503. So then just add and subtract, just like the formula tells you to. And I'm getting a squared is equal to 357.4969. And then again, we have to find just a, not a squared, so take the square root. So don't round here. Keep that answer in your calculator. And then we're getting a is approximately 18.91. And if you think about it, that kind of makes sense, right? So it's feasible that that's the middle angle, right? And then so that would be the middle side. Okay, so that's what we do if we have a side angle side situation. So two sides and the angle in between. But what if I have all three sides and no angle? Well, I can pick whatever angle I want, but I can find the angle that's in between two of the sides. So if this is like my angle A, and that's my side A, then I can make these B and C. Okay, so again, I'm using a squared equals b squared plus c squared minus 2bc cosine of angle A. Okay, so here we have all the sides. So we said side A is 14 squared, and then this is 12 squared plus 20 squared minus 2 times 12 times 20 cosine of A. So now our variable is over on the right-hand side. We're trying to solve for this angle. So you have to be very careful. That's why I have that reminder of order of operations. So as you do this, you have 196, 144, 400. This is what most people do incorrectly. They will try to subtract all of that and then divide by that. That's not how order of operations works. We have to do all the exponents first, and then do all the multiplication, and then do the subtraction. So be careful on how you solve. You don't want to lump all of those together. All right, so we'll figure out what the 2 times 12 times 20 is. That's 480 cosine of A. So now here's where you got to be careful. You can add these two together. That's okay. Okay, but you cannot subtract those two together. You need to move this over here. So we're going to be subtracting the 544. All right, so 196 minus 544. That gives us negative 348, and that's equal to a negative 480 cosine of A. So now you're able to divide by this coefficient in front of the cosine of A. So you're dividing by the negative 480. Okay, so I'm getting cosine of A is equal to 0.725, and that's actually the exact decimal. It's not rounded. And now I can do the inverse cosine. Remember, if I'm trying to find the angle, you use the inverse of that fraction or that decimal. All right, so second cosine of 0.725, and I'm getting the measure of angle A is equal to 43.53. All right, so that's what we know. We know that that angle right there is 43.53. All right, so we've done one of each. I actually want to do this one other one, and this is another side angle side situation, but notice which angle we have. So I wanted to do this one so you could see the connection between this law of cosines and the Pythagorean theorem. All right, so we have, if this is our a squared, and then we have our b squared plus our c squared minus 2bc cosine of our angle is 90 degrees. Okay, so, I forgot my squared. So x squared equals, if I do 73.24 squared, and then 21 squared, and then here, if you do just do cosine of 90 for a minute, and you get 0. So if you multiply all of that and then the last thing you're multiplying by is 0, that's going to give you 0. So think about what that means. If all of that goes away because the cosine of 90 is 0, the rest of this is really just a squared plus b squared equals c squared. All right, so we could have just done this with Pythagorean theorem, but I wanted you to see how the law of cosines gives you the Pythagorean theorem if you have the 90 degrees. All right, so then, yeah, you can just add those two numbers together. Which gives me this number. And then take the square root. So 76.2. Okay. So summary. We can use law of sines when we have angle, angle, side, angle. And remember, side, side, angle, that gives us ambiguous case, so we have to be careful there. You'll learn more about that next year. And then law of cosines, we can use side, 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 and side, angle, side. So if we have that, then we should be able to solve any triangle, not just any right triangle, but we should be able to find any angle, any side, using a combination of law of sines, law of cosines. All right?